There's some really important properties of logarithms that you need to be comfortable and familiar with. So we're just going to go through this list. Remember, the base of a natural log is always e. So we're saying that e is the base here, just to be aware. So what this is saying is e to some power is equal to 1. That's kind of the rewrite in exponential form. So that means that that power must be 0 because anything raised to the 0 power is 1. This one is a rewrite of e to what power gives me e. Well, that's always going to be 1. And then we have some multiplication and power properties. If you are multiplying two terms together inside one logarithm, that can actually be broken apart into addition as ln of a plus ln of b. And division can be broken apart into subtraction, ln of a minus ln of b. Now this one is pretty important. We see this one quite a bit. So if you have a power here, that can actually be moved to the front and treated as multiplication. We'll talk more about all of these properties as we go, but it's really important that we have good foundation of how to manipulate these properties. So I'm going to go ahead and write a couple of things over here on the side. Remember, log base e of x is the same as the natural log. So if you see the log, right, you're going to have to see a base there. If you don't see a number written, then there is a common base of 10. So if you see log base 10, or if you just see log of x, that's the same as log base 10. That's your common base. Also keep in mind, you can rewrite logarithms as exponentials depending on what you're trying to find. So if you have log base b of x equals a, that is the exact same thing as b, which is the base, raised to some power, which is the exponent, equals x, which is the value. So those are the same thing depending on what we're trying to find. We can also do ln of x. So the base of a natural log is always e. So e to the y is equal to x. So just keep in mind that that is one way that we may end up manipulating some of these functions. So let's go ahead and practice these properties. We're going to rewrite as a sum, difference, or multiple of logs on these. So we're trying to do a little bit of a rewrite. So I noticed that division is here. So I'm going to rewrite using subtraction. So I can write this as natural log of x squared plus 3 squared minus the natural log of cubed root, let me get that 3 in there, x squared plus 1. Now remember that I can also take that 2 and move that to the front. So I'm going to write 2 natural log of x squared plus 3. I'm going to go ahead and do this one in 2 different steps. But this is the same as x squared plus 1 to the 1/3 power. So now I can take that and also move it to the front. So you end up with, let me get an equal sign there. You end up with 2 ln of x squared plus 3 minus 1/3 ln of x squared plus 1. So that is a rewrite as a difference of 2 logs. So I took from 1 log into 2. This is actually going to be something that we do quite a bit because it's going to make our derivatives easier. So now we're going to condense. So that's expanding. So now we're going to condense. We're going to rewrite this as 1 log. So again, I can make that the power, and I can make that the power. So this is natural log of x plus 3 all squared plus the natural log of x minus 2 to the 1/2. And then because that's addition, I can write that as 1 log being multiplied together. So we're going to write this as x plus 3 squared, and then that's going to be times, and then I'm going to write this as just a square root. You don't have to. You could leave it as the 1/2 power, but that's condensing into 1 logarithm. Now, knowing that, I can actually do evaluations kind of quickly. So if I now have these values given to me, I can rewrite using ln of 2 and ln of 3. So ln of 12 is the same as ln of 4 times 3. Right? Well, that's the same as ln of 2 squared times 3. Now, you could do 2 times 2 times 3. That's fine. I'm just trying to show you one of the ways that we can manipulate. But because now I have one logarithm with multiplication, I can break that apart and write this as natural log of 2 squared plus the natural log of 3. Then I can use my property that says that 2 goes in the front. 2 natural log of 2 plus the natural log of 3. And now I know those decimals. Those decimals were given to me. If I had to do it by hand, I certainly could. But I can do 2 times the 0.6931 and then plus 1.0986. So I can add those together. If I had to do a little long addition, right, and carry the 1, all those things, I could absolutely do that. If you had access to a calculator, you could do that as well. But now I don't have to have a fancy calculator, I just have to be able to add and subtract in order to get my value. You also have a square root here, so if you know that you can change this to 2 to the 1/2, now you can just write it as 1/2 times ln of 2. And that's a pretty easy one to get to. So 0.6931. You can put a 0 in the front if you need to, but my decimal's pretty clear. So you ended up with 0.34655. I always like keeping a few extra decimals with logarithms. It actually comes in quite handy. If you round too early, you're going to significantly affect your answer with logarithms. So I always like to keep a few extra when possible.